Good afternoon. Thank you, Gabriel, for your invitation. Ladies and gentlemen, thank you for your participation. I am happy to be here. My name is Cristian Athanasovici, and I represent a very famous brand of motorbikes, because everybody of us knows very well the motorbikes of Kawasaki. But beside motorbikes, Kawasaki is doing a lot of other things which could be very interesting for our real life, domestic life, industrial life of today. So, I'm coming from Kawasaki Gas Turbine Europe. It is a daughter company of Kawasaki Heavy Industries from Japan. And you can see here in this slide which are the main divisions of, main sections of Kawasaki Heavy Industries Japan. So we are doing the ships. By the way, this was the first product of Kawasaki in 1881. So it's quite old. Japan, it's a country which have not the raw materials, so they were obliged to import everything. For this reason, it was a certain Mr. Kawasaki which started to build ships to transport raw materials. We are doing rolling stock, we are doing aerospace. We have a big division for energy system and plant infrastructure. As I told you, motorcycles and precision machinery, robots. You can see our offices. So in Romania, we have a representative office for Kawasaki Gas Turbine Europe, established in 2018. Here you will see turnover of Kawasaki Heavy Industries for the fiscal year 2020. And you can see the share per each section. So our energy division or energy system plant engineering cover around 16% from the turnover of Kawasaki Heavy Industries. Short history of Kawasaki Gas Turbine Europe. Kawasaki came in Europe in 1975. In 2003, they decided to make the facility production in Bad Homburg, near to Frankfurt Airport. In 2013, started the promotion of sales of gas turbines and gas engines. As I told you, in 2018, established in India, representative of. So, Kawasaki Gas Turbine Europe is manufacturer of gas turbine and gas engines. Equipments which are used for energy production, equipments which are used for cogeneration systems. Let's have a short look of context in which we are doing the business as Kawasaki Europe and also Kawasaki Japan. So we have, I can tell you that we have three main pillars of EU today under which we are doing the business. First pillar means decarbonization. The second pillar means decentralization of energy production. And the third pillar is the digitalization. And maybe today, after the war which is between Ukraine, Russia, and the crisis of natural gas, I would like to add the fourth pillar, which will say less natural gas. But we will see if we can do it or not. So, you can see here the main products of Kawasaki Gas Turbine Europe. As I told you, we are producing gas turbines between 1.4 megawatt electricity and 44 megawatt electricity, and we are doing the gas engines. So both technology for cogeneration, but in fact different equipments. Beside this product, we are covering some services which start with the pre-feasibility study, feasibility study. We are coming to customize the solution according with the needs of each partner, no client. never clients, partner, always partners. And after we finished with a long-term service agreement, so we are happy to sell our equipment and solution, but we'll be more happy if we can have a long-term service agreement. Without having maintenance is nothing. All equipment, doesn't matter the brand. Some features for our gas turbines, I don't want to insist. What I would like to emphasize is that this equipment is very useful for the industrial sector, which is needed the steam. So today we are talking about less gas consumption, go to photovoltaics, go to wind, and so on. Keep in mind that the steam cannot be produced using only the electricity. If you have steam at high parameters in chemicals factory, in refineries, for example, you cannot do it only with electricity. Good. Some technical features for each type of gas turbine. I don't want to insist too much. Main features for our gas engines. In this moment, we have the highest electrical efficiency for gas engines all over the world, 51%. This kind of equipment is very useful for the peak demand of electricity, for electricity production only. Why? Usually the PVs and the wind and so on, they are working in a base load of electricity demand, but this type of equipment, which is using natural gas, can start in 5 minutes from cold phase. It's very useful to cover the peak demand. Some technical features for our gas engines. I will jump over. This graph is very interesting, and I would like to show you the main difference between two technologies of cogeneration, gas turbines and gas engines. Gabriel, can you help me with a light?
This one.
Okay, thank you. So, we have gas turbine of 7.8 megawatt electricity and gas engine of 7.8 megawatt electricity. How much steam you can produce with both technology? For this reason, I would like to focus this aspect because it's very important, because define the market where are used the technologies. So, with the gas engine, I produce around 3 tons per hour of steam, and with my gas turbine, I can produce between 19 and 50 tons per hour of steam. This aspect of cogeneration defines the market of each technology. The main market of Kawasaki gas turbine Europe, pulp and paper industry, medicines, cosmetics, refineries, chemical plants, fertilizers plants. In all this is a big request of steam in the same time with electricity. But the request of steam is huge. I will give you an example. The Chiek soda factory, which is producing the soda, needs around 300 tons per hour of steam. So think to this aspect and think how you will cover this need only with the electricity. District heating. Our equipment fits very well the district heating systems, and I can summarize that we have two main markets, industrial market and domestic market district heating. Some examples of application of our solutions. You can see here a project in Portugal, which is using 2 different gas turbines which deliver steam to industrial customers and electricity to the grid. And here it's a application of gas engines in Japan. You can see here the total output of the power plant, almost 110 megawatt electricity. Remember that I mentioned before, this type of equipment, gas engines, are very useful for peak demand of electricity. simple approach of the Japan project based on gas engines. So up to now I told you that Kawasaki it's very good in them equipments based on natural gas. But I presented you the context of our business. So one of the pillars is decarbonization. For this reason, Kawasaki started few years ago, more precise in 2012, to think to hydrogen and to renewables. And to think also for distributed generation of energy. With the other words, do not use only the natural gas as fuel, to be more open to other type of fuels, and in the same time to be more close with our equipment to the client's needs, in order to avoid the losses for transmission and distribution, doesn't matter, electricity or heat. So, for this reason, Kawasaki developed so-called hydrogen roadmap. Today, hydrogen, you saw already that could be the main fuel in the future. How near or how long future, nobody knows today. We developed already several combustion chamber which can use same time natural gas and hydrogen. I remember you that if you want to burn something, you need the air, and in the air you have the nitrogen. So you have the emission of NOx. You have to do something with these emissions. For this reason, today we are ready with all our equipments to use maximum 30% hydrogen in a mixture with natural gas without having NOx reduction in so-called dry low emissions combustion chamber. But for the future, we are looking to have 100% hydrogen. We will have the nitrogen in the air, and we have to go with the NOx as low as possible. For this reason, our latest development is this type of combustor called micromix. So, the status of our equipments regarding usage of natural gas and hydrogen is the following. All our equipments are ready for 30%. But not only this, we are ready in the diffusion mode here, because diffusion mode it's a kind of technical process to avoid the NOx or to reduce the NOx. We are ready also with parts of our gas turbines to go to 100% hydrogen. As I told you, Kawasaki was the first in the world which built up a CHP plant in Kobe using 100% hydrogen. You can see here a very short or schematic of the site of CHP in Kobe Harbor. They deliver the steam to some industrial clients. They deliver the hot water for district heating, and the electricity also to some industrial clients which are located in Kobe. As I told you, this is our development for hydrogen of our gas turbines, and will follow very soon also our gas engines. Everybody is looking today to hydrogen. We were lucky this year. We sold to RWE the first gas turbine of 44 megawatt electricity, which will be used 100% hydrogen. The RWE planned that somewhere in the middle of 2024 to go in a commercial operation with our gas turbine based on 100% hydrogen. I would like to finish my presentation and to show you the capability of Kawasaki brand. Look here, start from the production of hydrogen. We can have hydrogen from fertilizers plant. We are doing the membranes for electrolyzers. We have the installation of liquefaction. Because in Australia, we liquefy the coal, we extract the hydrogen from coal liquefaction, and together with this system, which is Kawasaki carbon capture, we are making the hydrogen and we export from Australia to Japan. Second step of our roadmap, it's so-called storage. We have equipments to store the hydrogen. So we liquefy the hydrogen at minus 253 degrees Celsius. The loss of temperature due to the ambient temperature is 1 Kelvin per day. Going further, transport. We developed a lot of carriers to transport the hydrogen from ships to trucks. Equipment used of hydrogen, valves, fuel cell train, boilers, gas turbines, gas boost compressors, gas engines. So this is a corporate technology synergy. In my opinion, if I'm coming back to cogeneration, because also this nice lady, Mrs. Mariana, told us about cogeneration of Veolia, in my opinion, this will be the future of cogeneration plants. To run in a mixture with other technologies which produce the electricity, like solar panels, like electrolyzers, which will produce the hydrogen as fuel, and they are using the electricity from solar panels, and so on. But take care, in the industrial, we need always, if we are going today in a mixture of natural gas with hydrogen, it's better to provide such kind of installation. Carbon capture storage or carbon storage and usage. So, I will close here my presentation, and if you have an energy project or a challenge, an energy challenge, we provide green energy solutions and efficient solutions. So, maybe our solutions will bring you in a reality and closer project in the near future. Thank you very much.